What is the root of the distinction in the meaning of equality between C++ and Python? There appears to be an almost philosophical difference in the meaning of equality between C++ and Python. I became aware of this distinction through an attempt to do in Python something that is quite difficult in C++, distinguishing between two enum types when they are both just a wrapper for a set of integers, but the issue is broader than enums, hence the present question. If I write in C++ code such as the following, I fully expect that the equality comparison will fail. Indeed, it's a compilation error. You can't even compare two objects unless they are, just to get going, of the same type. And yet it appears that there is little, no, precedent in Python for equality comparisons raising errors. And if an object raises every time it is compared to a object of a different type, it will break any container it is added to. Indeed, writing reveals that there is no problem in comparing objects that should otherwise be incomparable. What, philosophically, is the root of this distinction in the meaning of equality between the two languages? Update. Part of my puzzlement at finding this out about Python is that so far every feature appears to have been designed with the intent of being natural, intuitive, even human, not that these can be defined in the first place. But consider that you are at the fruit section of a grocery shop and ask one of the apron chaps, "Could you tell me whether these oranges are Fuji or Red Delicious?" Surely no one could make sense of the question to venture an answer one way or the other. So the question is how to provide a response of incredulous in bits and bytes. Update 2. Too long to be a comment to a Giacomo Alzetta's comment, I respect your opinion. Still, from this point on, I will not respect a book on Python that does not dedicate a chapter, or at least a section, to pointing out that 3.1 is true, and that explains the background, whether historical or philosophical, for this. Being dynamically typed does not mean that one is so very cornered, because, for example, one has only a handful of available names A, B, and C to reuse a name for a very different meaning. Ultimately, it's not even a philosophical, but an engineering issue. How do you remove, or at least reduce, the chance that one among multiple people collaborating on a software project will introduce bugs in the system? Bugs that remain dormant, because the language is dynamically typed, and we cannot predict computation paths, are far worse than bugs that scream error.
The fundamental intent in Python has changed over time. At the start, and until late in the development of Python 2, it was essentially the case that any two objects could be compared. Even mixed-type comparisons that made no intuitive sense, like. In cases like that, it was actually the string names of the types that were compared, and the result above was due to that, as strings, int, list. This was driven mostly by a misguided, in hindsight, attempt to impose a total ordering on all objects. Looking ahead to Python 3, the intent changed and started to be implemented with the datetime module types, which were introduced in Python 2, mixed-typed, equals, and equals comparisons that made scant intuitive sense were to raise exceptions instead, while senseless mixed-type equals will always return false and senseless mixed-type not equal always true. Python 3 strives to act like that generally. Of course, there are exceptions. For example, when comparing objects of different numeric types, like integers and floats, they're usually coerced to a common type under the covers. I was deeply involved in these decisions and wrote the datetime module, so you can trust me on that. But as to what C++ intends, you'll have to ask someone else. Smile. A bit more info. I should add that, up until the introduction of rich comparisons in Python 2, all comparisons funneled through a CMP protocol. In the Python implementation, comparing two objects returned one of the integers in -1, 0, 1. _CMP_. Methods had no idea which of equals, not equal, and equals was actually desired. So while the compare any two things no matter what original design was disliked early on, it was technically difficult to get away from before rich comparisons were incorporated into the language. Then it became straightforward, if tedious.
It's not so much a philosophical matter as a difference between dynamic language like Python and a strongly typed language like C++. Because variables can hold any type in Python, and that type can change dynamically, it makes sense for the meaning of equality to be looser in Python than something like C++. You don't want exceptions to be raised because you asked whether two variables were equal. In principle, the exception would need to be raised at runtime since Python is interpreted, and in a scripting language you would much prefer the comparison to return false in this circumstance. Similarly, you can say something like, even though foo is not Boolean. So you have the concept of things being falsy, which is weird from a strongly typed world perspective, but useful in a scripting context. In short, the philosophical explanation rests on the respective philosophy of dynamic and strongly typed languages.
I see no one expanded on the C++ side, so here are my 2 cents. In C++, every object and variable has a definitive type which cannot change, so a type mismatch can be detected at compile time. Since the result of equality between two unrelated objects is duh, of course not, and C++ puts high value on detecting errors early, it simply doesn't compile at all.
Informatique, please discuss this